Welcome to this demonstration of using AWS IoT Analytics and Amazon QuickSight. In this video, I'll demonstrate a solution that runs on AWS to monitor remote devices. I'll start by using an AWS CloudFormation template to create a stack. The stack will create a device simulator that uses Amazon DynamoDB and an Amazon Elastic Container Service or Amazon ECS cluster, managed by AWS Fargate. Then I'll create resources in AWS IoT Core and AWS IoT Analytics to capture the device information and store it in a dataset. Finally, I'll show you how to create a QuickSight account and create an interactive chart to gain insights from the dataset. Okay, let's get started. The device simulator and the IoT components I'll be demonstrating are publicly available to be downloaded. Anyone who has sufficient permissions in their AWS account can deploy these resources. To find these resources, I'll go to aws.amazon.com/solutions and scroll down to Browse Solutions by Technology. Under Internet of Things, I'll choose More, and I'll look for remote monitoring of IoT devices. I'll choose this button to go to GitHub, where I can download the solution. I'll keep this page open and return to it in a moment. Now, I'm logged into the AWS Management Console, and I want to deploy the AWS solution I was just showing you. I'll start by creating an AWS Cloud9 Integrated Development Environment, or IDE, in my account. This will give me a convenient place to work in. I choose Create Environment, give it the name Demo IDE, and accept all other default settings, and create it. I'll pause the video for a moment and come back when it's ready. Great. The IDE is now available. Next, I'll go back to the browser tab where I have the GitHub page open and choose Code. I'll copy this HTTPS URL. Now back in the Cloud9 terminal, I'll type git clone and paste in the URL from GitHub and run it. I'll browse to the .yaml file, which is the CloudFormation template. This is what I'll use to deploy the device simulator. Before I run this CloudFormation template, though, I want to update a few details. First, I need to find the location of the container image from Amazon Elastic Container Registry, or Amazon ECR. I'll go to gallery.ecr.aws and search for IoT. I choose the one for remote monitoring of IoT devices and copy the location. Now back in the template, on line 562, I'll hardcode the location of the container image by pasting it in. This template can create all the IoT resources needed for the solution, but I want to show you how to create those resources manually in the console, so I'm going to delete the lines in this file that create those resources. I deleted the lines before this demo, so I'll paste in the updated file contents now. Note that other than the one line you saw me change, I didn't add or change anything else in this template. I only deleted some lines. In a moment, I'll show you what this template will still create. Now I'll go to the CloudFormation console. And from here, I'll choose Create Stack, and I'll choose Create the Template in Designer. Using Designer is convenient because I can create the stack without first creating an S3 bucket to upload the template file to. In the Parameters tab here, I'll choose Template, and then choose YAML, which is the format my template is in. I'll paste the template contents in from the Cloud9 editor and then refresh the graphical view of what the template will create. Next, I'll choose the Up to Cloud icon, which launches the Create Stack wizard. I'll choose Next and then enter the stack name, IoT Demo. I'll also set the number of devices to simulate to be 10. Now I'll work my way through the rest of this wizard, accepting all the default settings. I'll acknowledge that some IAM resources might be created, and finally, I choose Create Stack. I'll briefly pause the video until the stack is created. Okay, the stack has been created. Here in the Resources tab, I can see that this stack created 31 resources, including 1 DynamoDB resource, 23 EC2 resources. These resources create the VPC that the Fargate cluster runs in. 3 ECS resources, this is in fact the Fargate deployment, and 3 IAM resources, including 2 roles and a policy, and 1 logs resource. So let's quickly look at the device simulator components. Here in the DynamoDB console is the table that was created. If I choose Explore Table Items, you can see that it has 10 entries, one for each device. And now I'll go to the Amazon Elastic Container Service, or Amazon ECS console, and I'll select the cluster that was created. Amazon ECS is a managed container service that you can use to run containerized applications. Fargate can manage the cluster for you. In this demo environment, the device data simulator is running on an ECS cluster, which Fargate is managing. If I select the tasks view, you can see that there are 10 tasks running in this cluster, one for each device. Now that I have a device simulator, which is labeled 1 and 2 in this diagram, to send device information that AWS IoT Analytics can ingest, the next thing I want to do is create an IoT channel to receive the messages being sent. The channel, number 4 in the diagram, will create the IoT rule number 3, which you see here. But before I create the channel, I first want to create an S3 bucket to store data the channel will receive. I'll quickly go to the Amazon S3 console to create the bucket and name it my channel-bucket- and I'll just add some random numbers here. Next, I'll go over to the IoT Analytics console. I choose Channel and then Create Channel. Let's name it My Channel, and for storage type, I'll select the bucket I just created. I'll select this IoT role, IAM role, and choose Next. I happen to know that the device simulator publishes messages on a topic named remote_monitoring. Here in this IoT core topic filter, I'll search for that and choose See Messages. Notice that the messages are coming in from ECS. That's great. The channel is receiving data. For the IAM role, I'll select the IoT role and then choose Next. And finally, I'll choose Create Channel. Now let's take a look at the IoT rule that was created when I created the channel. It's here in the IoT core console, under Message Routing and then Rules. Notice the SQL statement selects everything that comes in on the remote_monitoring topic. And then under Actions, this data is sent to IoT Analytics. Okay, this is great. The IoT rule receives the data and feeds it to the IoT channel, as shown in steps 3 and 4 here. I can't create the IoT Analytics pipeline, number 5, until I have a data store. So I'll create the IoT Analytics data store next, and then I'll create the pipeline. Back in the IoT Analytics console, I choose Data Stores, and then Create Data Store. I'll give it the ID My Data Store. For storage type, I'll choose Service Managed Storage, and then specify a time period of 3 days, because this is simply a demo. Next, I'll keep the data format as JSON and choose Next. I'll choose Next again, and then choose Create Data Store. Great. Now that I have the data store, I can create the pipeline. I choose Pipelines, and then I choose Create Pipeline. I'll name it My Pipeline, and then select the source and output resources that I just created. Next, notice that the pipeline is able to infer the message structure. The data coming into the channel is in a structure that the pipeline can parse. I don't need to add any pipeline activities, but if I wanted to process the data before it's placed in the data store, this is where I could do that. Notice that a few transform and enrichment type activities are available. You can also filter messages conditionally. Later in this demo, I'll show you how to apply filters at the visualization layer. But for now, I'll choose Next and finish creating the pipeline. Now that the pipeline is created, I'll head over to the S3 bucket to see if the data is being written there. I'll drill down into these folders, also called prefixes, within the bucket. And notice all these GNU zipped JSON files. This is where the IoT Analytics data store I defined is storing the monitoring data for the remote devices. So the data is now being written to Amazon S3. I've built items 1 through 6 in this diagram. The next objective will be to get this data showing up in QuickSight. To do that, I need to create a dataset in IoT Analytics. I'll head back to the IoT Analytics console and choose Datasets. Notice what it says here. A dataset is a result of a SQL query run against your processed data. A channel, a pipeline, and a data store are required before a dataset can be created. The process data that this refers to is the data in my data store. I choose Create Dataset. Notice that the description of SQL datasets says, a SQL dataset is a materialized view from a data store. That's what I want, so I'll choose Create SQL. I'll give it the name My Dataset, and for Data Store Source, I'll select My Data Store. I'll run a test query and verify that the results can be returned. There they are. For the actual query, I'll want all the data though, so I'll remove limit 10 from the end of this query and choose Next. I could optionally apply a data selection filter, but I don't need one. For frequency, I'll choose every 1 minute. This will be helpful for demo purposes. Normally, for an analytics dashboard, I might choose something less frequent. Because this is a demo, I'll retain the data for 3 days. And great, now I have a data set. I'll choose the My Dataset link and then look at the content details. I'll choose Run Now. Remember, I just set it to run every minute, so I could just wait for the dataset contents to appear. Great, there's the data. I'll choose the name link, and here the results preview shows that the data is appearing in this dataset. That's great. Okay, so the monitoring data for the remote devices is in the dataset. In this last part of the demo, I'll show you how to create a QuickSight dashboard to display a customized view of the data. I'll start by activating my QuickSight account. I'll search for QuickSight here in the console's search field and choose that. I'll choose Sign Up for QuickSight. I'll keep Enterprise as the addition and choose Continue. I need to give it an account name. I'll type in my demo QuickSight account, followed by some random numbers, and I'll also type in an email address that I have access to. For IAM role, I'll use the QuickSight Managed role. And for services it will have access to, I only need IoT Analytics, so I'll select that and clear all these others. And finally, I'll choose Finish. I'll pause the recording while the account is created. It only takes a minute or so. Okay, the account is now created. I'll choose Go to Amazon QuickSight, and I'll close this What's New window. Great, so this is QuickSight. Some sample analyses appear, but I want to create a new one. So I'll choose New Analysis, and then choose New Dataset. For the source, I'll choose AWS IoT Analytics, and I'll give it the name My IoT Analytics Data Source. I'll select My Dataset to import, and choose Create Data Source. SPICE, by the way, stands for Super Fast Parallel In-Memory Calculation Engine. It's an in-memory engine that QuickSight uses. Some other data sources provide a direct query option as well. So finally, I'll choose Visualize. Now I see the screen where I can create a chart. Notice the fields list displays the fields available in my dataset. I'll set the visual type to vertical bar chart. Then I'll drag the device ID field onto the x-axis of the chart. Next, I'll drag temperature to the value field and configure it to display the average temperature. Finally, I'll drag oil level to the group color well. This is a crowded chart and it needs some formatting. First, I'll format the device ID so that it doesn't display a comma in the number. Next, I'll expand this chart to occupy the full sheet. It's still a crowded chart. It looks like it displays too much data. Let's apply a filter to reduce the amount of data and to bring more specific data into view. I'll choose Filters, Add Filter, and I'll select Oil Level. Now I'll choose the ellipses or three-dot icon next to this new filter and choose Edit to make some adjustments. Let's set the chart to only display oil levels less than 110. And I'll choose Apply to update the chart. This looks like a more manageable amount of information. It might allow me to find some interesting correlations between temperature and oil levels. But for now, I'll disable this filter. Let's say I notice that particularly high average temperatures occur on one device. I can drill down into those details. For example, I'll select one of the bars above device number 1004 and choose Focus only on 1004. That action applied a different filter, as you can see on the left. Now the chart displays specific information about this one device. If I hover over one of the highest bars in the chart, I can see that when the temperature of device 1004 hit 246 degrees, the oil level was 139. Is there a correlation between high temperatures and oil levels? If there is, this chart will help me figure that out. It's convenient to be able to drill down into such specific information in such a large data set. And by creating an interactive chart in QuickSight, you can expose this data to people who aren't as technical in your organization. As an end user of this chart, I don't need to know how to write custom SQL statements in order to extract information. I'll go back to the main view of the chart by disabling the filter. Next, I'll show you how to expose one of these filters to end users. I'll re-enable the oil level filter and then add it to the sheet. Let's give it the name Filter by Oil Level. I'll set the minimum value to 110, the maximum value to 200, the step size to 10, and choose Add. Okay, now I'm ready to publish this. I choose the share icon and select Publish Dashboard. I'll give it the name Remote Device Monitoring and choose Publish Dashboard. Now I have a dashboard that I can share with other users in this QuickSight account. Notice that it contains the Filter by Oil Level slider filter. Let's test that out. Looks like it's working. That's great. Now let's look at the options to share this dashboard. If I choose Share Dashboard, I can invite other QuickSight users or groups in this account to access the dashboard. And notice that I could also email this report just once or even on a scheduled basis. There are many customizable options here. In summary, in this demo, I've shown you how to use AWS IoT Analytics to capture monitoring data for remote devices. I also showed you how to display the data graphically using Amazon QuickSight. I hope you found this helpful. Thanks for watching.